Welcome to G Fun Facts Online. Today, we're cracking open the story of human civilization. But we're not starting with pyramids or empires. We're starting with a rock. Because for millions of years, the most important piece of technology on Earth wasn't a computer, it was a sharp stone. This is the story of how lithic technology, the art of making stone tools, forged our world. Our story begins over 3 million years ago in Africa, but it really gets going around 2.6 million years ago with what archaeologists call the Oldowan industry, named after Olduvai Gorge in Tanzania. The toolmakers, likely our ancestor Homo habilis, used a simple but brilliant method called hard hammer percussion. Imagine picking up one rock, the hammerstone, and striking another, the core, to break off a sharp piece. For a long time, we thought the big, hefty core, or chopper, was the main tool. But now, most evidence points to the real prize being the razor-sharp flakes that broke off. Microscopic analysis shows these flakes were used to cut plants and, crucially, to butcher animals. This gave our ancestors access to calorie-dense meat and marrow, a vital new energy source that literally fueled the expansion of the early human brain. It seems simple, but making that first cut required a huge cognitive leap, understanding material physics, planning ahead, and executing a sequence of actions. This wasn't just breaking rocks, it was the dawn of culture. Then, about 1.76 million years ago, the toolkit got a major upgrade. Enter the Acheulean handaxe, the signature tool of Homo erectus. This wasn't just a chipped core. It was a work of art and engineering. These tools were bifacially worked, meaning they were carefully flaked on both sides to create a symmetrical, teardrop-shaped tool with a continuous cutting edge. This required immense skill and forethought. The toolmaker had to see the final shape inside the raw stone before they even started. Think of it as the original multi-tool. It could butcher an animal, dig for roots, or shape wood. What's incredible is the consistency. We find these handaxes across Africa, Europe, and Asia, and for over 1 million years, the basic design barely changed. This suggests that the knowledge of how to make them was passed down through generations, a true cultural tradition. Some researchers even propose a fascinating tool-to-language hypothesis. Brain imaging studies show that the parts of our brain that light up when a person makes an Acheulean handaxe overlap with the regions we use for language. It's possible that the complex thinking needed for toolmaking and the development of language evolved together, hand in hand. Fast forward to about 300,000 years ago, the Middle Paleolithic. This era brought the Mousterian tool industry, associated with both Neanderthals in Europe and early Homo sapiens in Africa. The game changer here was the Levallois technique. This was a revolutionary method of production. Instead of just chipping away at a core to shape it, the toolmaker would first meticulously prepare the core, shaping it almost like a tortoiseshell. Then, with a single, precise strike, they could detach a perfectly formed flake of a predetermined size and shape. It was incredibly efficient, saving raw material and producing a consistent product every time. This allowed for a whole new level of specialization. Suddenly, you have a diverse toolkit: side scrapers for preparing animal hides, sharp points that could be hafted onto spears, and denticulates with serrated edges for working wood. This wasn't a one-size-fits-all approach anymore. It was about having the right tool for the right job, showing advanced planning and adaptability. Around 50,000 years ago, something incredible happened. The Upper Paleolithic period began, and with it came an explosion of innovation, mostly associated with anatomically modern humans, Homo sapiens. The new star of the show was blade technology. Instead of one flake from one core, toolmakers could now strike off dozens of long, thin, standardized blades from a single prepared core. It was mass production, Stone Age style. The amount of cutting edge they could get from a single piece of flint skyrocketed. But they didn't stop there. These blades were then transformed into an astonishing array of specialized tools: burins for engraving bone and antler, end scrapers for meticulously cleaning hides, and deadly projectile points for hunting. And for the first time, we see widespread use of other materials. Bone, antler, and ivory were fashioned into eyed needles, meaning our ancestors were sewing tailored clothing to survive the cold. They created harpoons for fishing and, perhaps most impressively, the atlatl, or spear thrower. This device acted as a lever, dramatically increasing the range and power of a thrown spear. This period also gives us our first undeniable art: stunning cave paintings, intricate carvings, and personal jewelry. This suggests a new level of symbolic thought, complex communication, and the birth of distinct cultural identities. After the last ice age ended around 12,000 years ago, the world changed. The climate warmed, glaciers retreated, and forests spread across the landscape. The massive herds of mammoth and woolly rhino disappeared. Humans, ever adaptable, changed their technology to match. This period is the Mesolithic, or Middle Stone Age, and it's defined by tiny tools that led to big changes: microliths. These were small, geometric stone pieces, often just a centimeter or two long. They weren't used by themselves. Instead, they were components in composite tools. Imagine setting a row of these tiny, sharp blades into a wooden handle to create a sickle for harvesting wild grains, or using a single one as a barb on an arrow. This modular design was genius. It was versatile, and if one small piece broke, you didn't have to throw away the whole tool. You just replaced the broken microlith. This technology reflects the ingenuity of hunter-gatherers who are now exploiting a much wider range of resources: smaller game, fish, birds, and a vast array of plants. The next great leap, beginning around 10,000 BCE in the Near East, was the Neolithic Revolution, the invention of agriculture. As people settled down to farm crops and raise animals, their tools had to change too. While chipped stone was still in use, the defining technology of the Neolithic is the ground and polished stone tool. Instead of just flaking, toolmakers began pecking, grinding, and polishing hard stones like basalt and granite to create incredibly durable and effective tools. The iconic tool of this era is the polished stone axe. You can't start a farm without clearing forest, and these axes were essential for the job. We also see the invention of sickles, with sharp flint blades for harvesting grain, and grinding stones like querns and pestles for processing that grain into flour. These tools were directly tied to the new farming lifestyle. Interestingly, many of these tools are polished to a degree far beyond what's functionally necessary, suggesting they also held aesthetic or social value. A beautifully polished axe wasn't just a tool. It might have been a status symbol. So how do we know all of this from a bunch of old rocks? Archaeologists have a sophisticated toolkit of their own. The most fundamental method is lithic analysis, where they study the tools themselves and the waste flakes, or debitage, to understand how they were made. Then there's use-wear analysis. By putting a tool under a powerful microscope, researchers can see tiny scratches, polishes, and residues left behind. These microscopic clues can tell them if the tool was used to cut wood, scrape hide, or butcher an animal. To confirm their findings, they use experimental archaeology. Scientists learn to make stone tools themselves, a process called flint knapping, and then use these replicas for different tasks. This gives them a first-hand understanding of the skill involved and creates a reference collection of wear patterns to compare with ancient artifacts. A cutting-edge subfield called neuroarchaeology even uses brain scanners to see what parts of the modern human brain are activated during toolmaking, giving us incredible insights into the cognitive evolution of our ancestors. But the Stone Age couldn't last forever. The transition to metal was gradual, not a sudden switch. The Chalcolithic, or Copper Age, saw the first widespread use of metal. At first, copper was mostly used for jewelry and small items. It's a relatively soft metal, so for many jobs, a good flint knife was still better. The real game changer was the Bronze Age. By mixing copper with tin, people created bronze, a much harder and more durable alloy. This led to swords, armor, and more efficient plows. However, bronze was expensive. You needed access to both copper and tin ores, which were often traded over long distances. For the average person, stone tools remained the cheap, reliable, everyday implements for centuries, used well into the Bronze Age and even the Iron Age. The story of lithic technology is the story of humanity. For over 99% of our history, stone was the foundation of our existence. The simple act of striking one stone against another sparked a revolution that shaped our hands, our brains, and our societies. The cognitive skills we developed, planning, problem-solving, fine motor control, and teaching, were all honed on the whetstone of lithic production. These skills didn't vanish with the Stone Age. They laid the groundwork for every technological leap that followed, from the bronze sword to the printing press to the microchip in the device you're listening on right now. The sharp edges of the past didn't just cut and scrape. They carved the path to our modern world.